Hello dear student, myself Professor Ashok Kumar. I welcome you to my video lectures, and today we are going to discuss very much important chapter, that is chapter number 2, synthesis and analysis of mechanism. Basically this chapter comes in subject of kinematics and theory of machines, which is offered by university during the 5th semester degree mechanical engineering. Before starting our core content regarding this video lecture, let me introduce myself. Myself, Professor Ashok Kumar. I am working in Department of Mechanical Engineering at Dr. Subhash Technical Campus. Before having the synthesis and analysis of various mechanisms, let's discuss about an introduction regarding what is synthesis and analysis. Basically, we have seen, as you have seen that my previous video lecture, that the analysis of any mechanism generally aims to determine the performance, or we can say that the motion characteristics of any mechanism. Whereas synthesis of mechanism may be treated as a reverse problem that of the analysis. That means the prime goal to have the synthesis for the any mechanism, which is the motion study on motion characteristic. So that means if you are analyzing any mechanism, then we can say that it's the kind of determining the performance or the motion characteristic. Whereas if you are performing synthesis to any mechanism, then we can say that it is the designing a mechanism which generally satisfies the particular motion characteristics. So synthesis of mechanism is the way of designing of mechanism to produce a desired output motion for the given input motion. So kind of the motion behavior that will be discussed in case of synthesis problem. If you are giving some input as a motion, and whatever you are getting the output motion as output, that specially study focus or treated as a synthesis. Now, particular in this video lecture, some techniques for the design of 4-bar chain and sliding crank mechanism we will discuss. And in synthesis mechanism, generally entire problem for the analysis of synthesis for any kind of mechanism is basically divided in three main categories. One is the problem divided in first category is type synthesis, second is number synthesis, and third one is the dimensional synthesis. If you are talking about the type synthesis, then it refers to selection of mechanism. That means which kind of mechanism that you are using for the required motion as output. So over here, type synthesis just select the kind of mechanism, and for example, your mechanism will be have the like gear drive, belt or chain drive, or it may possible that your mechanism is of the cam and follower mechanism. But whenever you are selecting the type of mechanism, you have to consider design aspects like for example manufacturing process, material selection, space required, safety point of view. So along with the selection of mechanism, some other aspect is also included in case of type synthesis. Similarly, if you are going for the number synthesis, then it simply refers to determination of numbers of links and numbers of joints that is required for the specific output motion. That means in second stage of the synthesis, that is the number synthesis, the ultimate goal of number synthesis is to determine whether which numbers of the links which will be used for the particular required motion output in that particular we can say that the mechanism. Suppose you are selecting slider crank mechanism and you require some kind of output motion, so how many links and joints that you required at the end to have the output motion like. So number synthesis just determine the numbers of joint as well as the numbers of links. Whereas the dimension and synthesis, if we are talking about dimensional synthesis, then it refers to find out the dimension of mechanism. That means whatever the geometrical dimension required, for example length of the link, width of the link, even diameter of the link, and numbers of geometrical other dimension too. All that geometrical dimensions are determined, or we can say that the calculated in third stage of the synthesis, that is the dimensional synthesis. So we can say that actually mechanical design comes and it plays vital role in case of dimensional synthesis. So basically for any mechanism to be synthesized, there are basically three prime steps. Number one is the type synthesis, in which you are selecting the kind of mechanism that you are using for the output motion requirement. Number synthesis then after. So number synthesis means in that particular stage you have to calculate or determine numbers of joints and links that are required for that particular selected mechanism. And last stage include the dimensional calculation, that means geometrical parameters like length, like width, like diameter, whatsoever. Such geometrical dimensions are calculated within the last, that means third stage of synthesis, that is dimensional synthesis. Now after basic understanding about analysis and synthesis of mechanism, now it's time to focus upon purely on synthesis problem. So entire synthesis procedure, or say the problem solving technique, is divided basically in three categories in which or through which you can have the synthesis analysis. First category to which you are solving any mechanisms, and that is we can say that the function generation. Secondly is the path generation, and third one is the body guidance, or we can say that the motion generation. So let's see one by one all that three steps of the classification of a synthesis problem, and we are going to start the first and most important, that is function generation. Generally it is observed that it is frequently required in synthesis of mechanism that an output link must be rotate or oscillate, or we can say that the reciprocate according to prescribed motion, or we can say that according to specific time as input motion. So in function generation, the problem solving techniques lies on the two prime categories, or we can say that the two variation that is very much that plays very much important role in the function generation problem solving technique. One is the output motion, like it should be oscillating motion, it should be rotating motion, or we can say that it have the reciprocating motion. But that particular motion is of course related with the input time that you have given to generate such type of motion. So while solving any mechanism, it is very important whether the output link has which type of motion, that means reciprocating motion, oscillating motion, or the rotary motion, and which periodic time required to achieve this type of motion. That is very important. So entire phenomena, by considering the time or the periodic time with that particular output motion, that will be known as a function generation. Now if you are taking a simple example of this function generation, then is that if you are synthesizing a 4-bar mechanism to generate the function like y is equal to f of x, then we can say that x would represent the motion, or we can say that the angle of input link, and mechanism is to be designed such that the motion, or we can say that the angle of output link would be approximately work like y is equal to f of x. So over here we can say that y is equal to f of x is the representation of function generation, where you can say that the x is the representation of motion of output link, whether it is a rotating motion, that means there is a angle, some angle done by the output link, or there is a reciprocating motion, or even an oscillation motion. So based on that, we can say that this displacement, or we can say that the movement of that particular ring is directly related with the angle done by that particular output link. After that, the second we can say that the classification of problem solving technique through synthesis is the path generation. Now in path generation, a point one coupler link, or simply link, is to trace a described path with reference to fixed frame or reference. That means In path generation technique, basically what happens, there is a common point which is located, look at the diagram first. There is a kind of common point, and if you are rotating this entire mechanism in either direction, this common point will move and trace some kind of specific path. So this technique is of course represents the motion as well as the output link characteristic in that way. So we can say that this technique, if you are adopting, of course it will be known as a path generation. From figure you can see that as you are moving input link of the mechanism that you have given, like if you are rotating crank in this direction, all link will have some relative motion with each other, and ultimately due to rotation of crank by some angle, say 360 degree or even 180 degree, this coupler point P will trace some particular or specific path, and that path may have the form of an ellipse, arc or circle or even straight line. So whatever the form that is being generated by the coupler point or common point or contact point, it will give us the characteristic of the motion of, we can say that, the outlink link. So from path generation technique we can easily identify the which kind of the characteristic of outer link has while transmitting motion and power. And then if you are talking about the third technique, that is body guidance or motion generation, then in particularly we can say that in this technique the entire body is guided through a pre-selected sequence of motion. That means if a body is guided usually as a part of coupler link and you are making an analysis, it will be known as a body guidance. The name gives the concept of this technique, body guidance. As in case of path generation, we have selected a common contact point P, and as you are giving rotation to crank, the P moves in some curved or ellipse path. But in case of selecting P as a contact point, if you are selecting entire body of the mechanism and you are generating any kind of curve or any kind of the profile, it will be known as a body guidance, or we can say that the motion generation technique. Generally this type of analysis is being done in especially for the bucket and blades of a bulldozer, wherein we have seen that the bucket and blades of the bulldozer, actually bucket is not the kind of any kind of point, but it assembling the lots of the links, and entire bucket structure is treated. If you are treated it as a entire body, then what happens, bucket will move up and down or forward and reverse direction. So this concept can be easily adopted and treated as a body guidance concept. So up to now we have discussed about synthesis, its different three techniques, that means function generation, path generation, and body guidance or motion generation. And also we have also discussed about the types of synthesis, that means the number synthesis is there or dimensional synthesis. Particularly this is the point number 3, and in which we will going to discuss dimensional synthesis. As already we have discussed earlier that in case of dimension synthesis, just you have to determine the dimensional parameters of various links of a particular mechanism. The dimensions parameters may be the angles, maybe the distance, maybe the diameter, maybe the width or thick, whatsoever. So dimensional analysis, or we can say that the dimensional synthesis purely relate with the determination of dimensions or various dimensions of links, angles between the links, etc. And basically there are two ways through which you can have the dimensional synthesis analysis of any mechanism. One is graphical method and other is analytical method. Still if you are using graphical method, you have two options. One is inversion method and other is the relative fold method. So both graphical and analytical method generally are available for the dimensional synthesis, and which kind of the techniques, or we can say that the synthesis type you are selecting, it purely depends on which kind of problem that required to be solved. Either it is a problem related with 4-bar chain mechanism, standard crank mechanism, or other mechanism that you have given, and what is the prime requirement. Application area and need and the requirement over here suggests the selection of the method, whether graphical method should be selected or an analytical method should be selected. After that, you have to draw a line from point D1 with an angle 5 like that. Magnitude of this link D1C1 is still unknown, but just you have option that you can draw a line D1C1 with an angle 5. After that, draw an arc D1A1 by keeping D1 as a center. That means you have to draw this arc A1 A dash with an angle 512. So ultimately it gives the new point that is A dash. Similarly, take D1 as a center again and take D1 B2 length and draw an arc like B2 to B2 dash with an angle 512. It will give one more point, and that is the B2 dash. Now just once you are intersecting and getting the A1 dash, A dash and B2 dash point, just now you have to take again two arcs, and this arc should be taken by taking the center as A1 dash, A dash and B2 dash, and you have to draw an arc which intersect the point C in that manner. So simultaneously kindly consider and take the center A dash and draw an arc like that. Also consider center B2 dash and draw an arc which intersect at point C. Now once you are getting by intersecting both of the arcs which is taken from A dash and B2 dash, and we are locating final position of C1 as a point, kindly join both of the points B2 dash and C1 like that. So ultimately we are getting a new point, that is C1. Initially we have getting the fixed location of a point C1. So if you are analyzing now this graphical analysis of through inversion method, you can conclude that the link A1, B1, C1 and D1 that is shown on the figure, it indicates the first position. That means A1, B1, C1 and D1, this is the first position, whereas A1 dash that means this of course B2 dash, C1 and D1, that means this position of the mechanism shows the final position of the mechanism that you have given. And if you are comparing the both of the diagrams, you can conclude that B1 C1 or say B2 dash C1 will give the length of link 3. Of course this will the representation of link 3 that will be give or you can measure from B1 and C1. So this link if you are measuring that, of course the magnitude of this link will represent the link 3. And D1 C1 if you are measuring, that means if you are measuring this we can say that the dimension, then D1 C1 will give the dimension for the link number 4. So ultimately we can say that through inversion method you can have the dimension of link 3 and link 4. So as I have told earlier that through this graphical method in especially dimensional synthesis, we can measure various angle like theta 1 2 5 1 2, length of link 3, length of link 4, etc. In that way we can have all the determination of all the dimensions of various links. So dear student, this was an inversion method that we have discussed. After that, the second types of the method that we are going to discuss, that is the relative pole method. Generally, pole is a center of rotation of moving link relative to a fixed link of mechanism. That means, suppose if there are any 4-bar chain mechanism in which specially there is a one fixed link, like A1 D1 given to you is a fixed link, and centers of link 2, 3 and 4 are rotating with respect to this fixed link A1 and D1. Of course, we can say that it is nothing other than the pole. Now, to locate the pole point, kindly consider a 4-bar chain mechanism A1, B1, C1 and D1. Look at the screen, and in which specially link A1, D1 is fixed link, whereas A1 and B1 place at initial rotation through an angle theta. So over here, A1, B1, C1 and D1, that is the mechanism that given to you, in which specially A1, D1 is the fixed link, whereas A1 and B1 is initially given a rotation like theta. So this is the mechanism constructional detail. Now if the crank A1, B1 is rotated by angle theta suffix 1, 2 like that, in anti-clockwise direction, if you are rotating to finding the new position, that is A1, B2, then the output link C1, D1 rotates by angle phi 1, 2. That means this, because all the links are internally connected, and if you are giving some angular displacement to initial link A1, B1 to reach a final position A1, B2, simultaneously the end link, that means D1 and C1 is also get rotated by an angle phi 1, 2 and having the new position like D1 and C2. And due to this rotation of both of the links, crank 2 and output link 4, of course coupler link number 3 is also find its new position like B2, C2. Now just you have to draw two line which is normal to the link A1 and we can say that the C1 and D1, and which will intersect at some common point. That point is generally known as a point R, and basically that the point is the center of rotation of coupler link relative to the fixed link A1 and D1, and what it said, it is the, we can say that the pole point, or we can say that it is simply a pole. So in order to locate the pole point R, what we have done, we have just joined firstly two nodes A1 and D1, and again we have rotated the link A1 D1 like that, A1 and D1 about point A1 through an angle theta 1, 2 by 2 in the opposite direction to that of link A1 and B1. That means A1, B1 if rotating in this direction, A1, D1 should be rotating this direction. So this is the second step to locate the pole point R. And lastly, what we have done, we have rotated the link A1 and D1 about the point D1, and which should be rotated through an angle phi 1, 2 divided by 2 in the direction opposite to that of the link C1 and D1. Of course, this link A1 and D1, by keeping center now D1, and you are rotating this link, entire link A1 D1 opposite to the that whatever the C1 D1 has the rotational direction, you are getting the new position like this. So in that way, the point of intersection of both of the rotational motion, or we can say that you are getting one common point, because you are rotating entire link A1 and D1 by keeping one time A1 as a center and other time D1 as a center. Of course you will have the common point of intersection at point R. So in that way you can decide and locate the pole point. So this was the relative pole method that we have discussed. After that, point number 4 that we are going to discuss, that is the types of error in function generation. That means whatever the synthesis technique you are using, which kind of probably error are being produced, that we are going to discuss. First and most important types of the error that you are finding while designing through synthesis is the structural error. Basically, structural error is the difference between a generated function produced by synthesized mechanism and the desired function. We can say that it is the structural error. In short, we can say that whatever you have generated the function and whatever the desired or required the function, if you are finding any difference between both of course it will be known as a structural error. And generally it is not possible to produce accurate function y is equal to f of x, because there is some limitations and accuracy of the synthesis technique. So the position at which the generated function produced by synthesized mechanism and desired function is agreed are known as a precision position. Ultimately, the term precision position is the kind of agreement between the desired and we can say that synthesized function, because we know that the desired function is never possible to achieve through synthesized function. So there will be any little bit difference always present between there. So that if you are your synthesis function reach very closely to that the desired function, of course it will be known as a precision position, or we can say that the precision point. So structural error is 0 to be considered as a precision position, and of course the structural errors are reduced, or we can say that it will be minimized by once again rearranging the precision points, or by increasing the numbers of precision points generally which are used for the synthesizing of the mechanism. So this is the structural error. In order to remove the structural error, just you have to increase the numbers of precision points, or you can say that the precision points. And what I said earlier, precision point or the precision position is actually closeness. We can say that the degree of closeness to which your synthesis function reach to that exactly required function. Now secondly, error that you are finding while synthesizing any mechanism, that is mechanical error. And of course it is produced due to mechanical effect, mechanical defects, like improper manufacturing is there is no matching between two links, clearance is there between two links, there is a backlash for play between two links or the joints. So it causes the kind of error, and that will be come under the mechanical error. Generally, joints, rubbing joints, we can say that the elasticity of links, deformation due to external loading, or the force for power transmission, such type of the problem may arise. Such type of defects may be rise due to power transmission through any mechanism. So this was the mechanical error. Third and last one, that is the graphical error. Basically, graphical error produced due to unavoidable inaccuracies of drafting, like if you are following wrong graphical method, that means if you are selecting a wrong choice of scale, wrong graphical procedure you are following, then whatever the error produced, that will be known as a graphical error. Generally, minor graphical error arise due to wrong layout, wrong selecting angles, drawing parallel or perpendicular lines, that will be caused to have the minor graphical error. And generally, graphical error are distributed at random over the entire range of motion of the mechanism. Generally, graphical error are also depends on the designer's skill and judgment. That is very much important while you designing and graphically constructing any mechanism. And then after, types of defect that are being produced during the synthesizing of mechanism is basically there are two types. One is a branch defect, another is the order defect. If we are talking about defect and error, generally what happens in case of defect, Problem may occur due to some physical phenomena. That means if you are finding any mechanism with improper balancing or the vibration that are being set up, so it will be known generally it goes through some kind of deformation through links of the entire mechanism, or we can say that there is a joint to be loosened out. So all that kind of defects we should to concentrate and try to minimize while synthesizing the any mechanism. Look at the screen. There are basically two types of defect that are being produced. One is branch defect, another is the order defect. If we are talking about the branch defect, generally it is produced in a crank and rocker mechanism, or we can say that the double crank mechanism. For example, if you are taking an example of an IC engine, there is we can say that the crank and rocker both are used for operating we can say that the inlet and exhaust valve. So it may possible that the branch defect play a vital role there. It may possible that a set type of defect will arise while transmitting motion and power. In order to minimize this defect, the links of the entire mechanism, that means crank, rocker or double rocker, should be arranged to maximum number of precision points. Again, we are coming for the precision points in order to remove the error or say the defects. Earlier in previous slide I have said that in order to remove the error or minimize the error, your synthesis procedure should be in such a way that there should be a maximum number of precision points which result into minimization of the every error, or we can say the defect. If we are talking about the order defect, generally it is produced in double rocker mechanism, and in order defect, if synthesized link satisfies the order, like for example 1, 2, 3, 4, then precision points no longer follow the same order. So this is the cause, or we can say that the reason why order defect arise. If your 4-bar chain mechanism having the order of 1, 2, 3 and 4, then precision points should be also follow the same order, but it's not happen in real manner. So if you are finding that there is a mismatching of order between links, synthesized links and precision points, of course it result into order defect. For example, suppose input link move from 1 to 2, that means theta 1 to theta 1 dash, for example. Of course synthesized link will also move from phi 1 to phi 2, but still you are moving input link. There will be no guarantee for the synthesized link to move from either phi 3 to phi 4. If this mismatching of following movement by synthesis link to input link is arise during the operation, or say power and motion transmission, of course it will be the order defect. So dear student, this was the lecture specially I have taken on synthesis, and we have discussed a lot about graphical method, types of error, types of defect. Still you are having any question regarding this entire video lecture, or any topic, or the difficulty regarding any subtopic too, let me inform. We have the solution. Thank you very much for your attendance to my video lecture. Thank you.